On September 12, 2025, skywatchers detected an unbelievable sight. A massive entity hurtling in from the outer cosmos, its trail extending roughly 5 times broader than a full moon's diameter, overshadowing any spectacle since Oumuamua. Shortly after, confirmation arrived for a second intruder. The pair hurtling toward the sun for near encounters just weeks apart, yet originating from diametrically opposed regions of the heavens. Experts peg the probability of this stellar duo's arrival as staggeringly remote. The standard explanation? Paired comets. Yet clues suggest deliberate construction. Now, a larger enigma invades our solar neighborhood, purpose unknown. Could this be a cosmic mishap or the opening gambit in a covert scheme we've unwittingly set off? The unraveling begins here. That very day, the Swan instrument aboard the Soho spacecraft captured an image that left astronomers stunned. A fresh anomaly, vivid and undeniable, streaking across the solar domain. Data flooded in rapidly. The appendage spanned almost 2.5 degrees in the sky, equivalent to 5 full moons side by side. Such proportions are unprecedented for a freshly identified comet. Early brightness readings clocked it at magnitude 7.4, visible through modest home telescopes or even certain binoculars. Word raced through the network, prompting hobbyist stargazers to verify the satellite's findings. In Australia, merely 2 days post-alert, one enthusiast snapped a striking photo of the intruder. A luminous streak so extensive it nearly overflowed the lens. By September 13th, the International Astronomical Union formalized its designation, C/2025 R2 SW, honoring the detecting device. Over the ensuing weekend, pros and amateurs alike fixated on it, exchanging snapshots and luminosity data across the globe. The immense scale and glow ignited rampant conjecture. Contemporary comet finds tend to be dim specks, demanding hefty equipment for a glimpse. SW, by contrast, shone for anyone with basic directions, its tail carving through Virgo, intensifying as it neared the sun. The first responses mingled thrill with skepticism. This went beyond a routine frozen wanderer from the fringes. The metrics defied modern benchmarks. As updates accumulated, a pattern emerged. Swan commanded the inner solar system with a presence unmatched since Hale-Bopp, or perhaps even earlier icons. Hobbyists, quick to notice flux in intensity or peculiarities, pondered what force could propel such an elongated, radiant tail. For the moment, the visitor's enormity, brilliance, and velocity demanded attention. As observatories worldwide monitored its trajectory, inquiries evolved, from its identity to the rationale for its timely entrance, and if that schedule hinted at a broader, odder conundrum. C/2025 R2, dubbed Swan officially, isn't the sole fresh arrival captivating eyes this October. Days prior to its reveal, 3i/Atlas was already en route, approaching from an entirely distinct sky sector. Swan's trajectory hails from Aquarius, whereas Atlas originates near Sagittarius. On celestial charts, their entry paths diverge by over a quarter of the vaulted sphere. Still, both are poised for perihelion, their solar nearest, inside a mere 10-day span. Swan's peaks around October 20th at roughly 150 million kilometers out. Atlas hits on October 17th, 3 days sooner, grazing the sun at about 203 million kilometers. That situates their closest solar points a scant 50 million kilometers removed, tighter than Mars' typical Earth proximity. This transcends mere date overlap. The layout is uncanny. Each follows a sharply angled orbit, with Swans deviating over 60 degrees from the ecliptic and Atlas almost at right angles to the planetary disk. Their ingress directions vary so sharply that, by pure happenstance, the chances of simultaneous inter-system transits at comparable solar ranges shrink to near impossibility. Those monitoring extended orbit comets and extrasolar wanderers expect erratic timings, with solar grazes dotted across months or years. Yet these two most luminous novelties of the decade sync up toward the sun almost in tandem, each from opposing celestial quadrants. The schedule compounds the intrigue. During Swan and Atlas's solar sweeps, terrestrial scopes face obstruction. From October 8th to 18th, solar brilliance hampers straight-line views. forging a blind spot enveloping the pivotal period when anomalies might shine clearest. Thus, their mutual solar and interpersonal nears occur precisely beyond easy scrutiny, with there simply no means for earthbound watchers to monitor these happenings as they occur live. Having two celestial bodies from such distant starting points reach their closest solar approach mere days apart, at almost identical distances from the Sun, right when the star itself blocks any direct sight of them. This setup challenges the odds one would normally anticipate. In orbital mechanics terms, we're dealing with a pathway, a tight slot in both space and time that these two share. Is it pure luck, some concealed connection, or deliberate design? That's still up for debate. Yet the layout by itself is compelling enough to give even the biggest doubters in astronomy second thoughts. The object known as 3/Atlas initially caught eyes not because of its glow, but due to how it upended the norms. Initial spectral analyses from the Atlas Spec Lab crew flagged an issue that raised red flags. A composition heavy on nickel, with practically zero iron present. This clashes with standard comet profiles, where vapor trails typically reveal a mix of iron and nickel. The revelation was so outlandish that certain facilities promptly demanded a double-check on the readings. What followed was a dispute over instrument tuning that leaked into online astronomy discussions and sparked a flurry of separate verifications. Tensions escalated further with fresh observations. Rather than the expected water vapor signals, the coma around 32/Atlas released carbon dioxide at levels five-fold greater than water. The 4.3-micron CO2 feature overwhelmed all readings, while H2O signals scarcely rose above background static. Such traits aren't unprecedented in comets from frigid outer regions, though. Far tougher to dismiss was the tail's odd conduct. Those following Atlas's path spotted irregularity, 3 separate speed boosts, roughly 2 weeks between each, aligning with abrupt shifts in the tail's hue. The initial surge hit on July 29th, the follow-up on August 14th. Imaging records captured an abrupt surge in luminosity, accompanied by the spectral profile swinging from red-tinged to almost flat, then reverting. These events, dubbed Delta 5 bursts, lacked the even progression of sunlight-driven evaporation. They struck suddenly, then ebbed, resembling bursts from an onboard propulsion system. Experts reviewing the work raised concerns about potential instrument drift or overlooked biases. Yet the Atlas Spec Lab group stood firm, noting that the burst schedule and scale aligned across various sites, from the Abro monitoring grid to Bill Gates' scattered telescope setup. The figures didn't align with ordinary gas releases. The tail's CO2 content appeared to fluctuate right alongside each boost, a pattern dubbed thrust blend variation by some. What truly ignited wild theories was the power calculation. Assuming those boosts were genuine, the internal energy supply in Atlas would have to generate around 10 gigawatts, equivalent to 10 major nuclear facilities. That's way outside the capabilities of any recognized comet core. Consensus opinion maintains that natural mechanisms explain much of the evidence, but the discrepancies, particularly the nickel-heavy readings and the staggered boosts, sustain talk of artificial origins. At present, the Atlas puzzle stays unresolved, with incoming data stoking doubt and conjecture alike. C/2025 R2, rechristened Swan, occupies its own category entirely. The stats paint a vivid picture, a tail spanning 2.5 degrees, a luminosity crest matching the top performers from the past 100 years, and a nucleus that, per the most audacious projections, might be unleashing 10,000 gigawatts of power. That's surpassing the total electrical capacity of our planet by a wide margin. Yet beyond the sheer magnitude, it's the assertions from astronomy's outer edges that have folks buzzing. Suggestions that Swan features protective layering, defensive barriers, and drive systems pushing beyond established science. The murmurs began with the reflection measurements. Typical comet hearts diffuse sunlight in familiar patterns, but Swan's center bounces back rays with a distinct metallic profile. A few hobbyist spectrum experts claim this echoes not only nickel, but a nickel-cobalt alloy, substances prized on our world for durability and anti-rust properties. Phrases like nickel-cobalt shell started popping up in forums and overnight broadcasts, driven by the body's persistent wholeness and steady shine as it neared the sun. Next arrived accounts of a visual oddity, a steady silver glow encircling the core, varying in form and strength. For certain observers, it evoked a plasma sheath, an energy field repelling solar particles and space junk. Hence the moniker Fortress. In contrast to 3-2/Atlas, which behaves like a nimble scout, swift, maneuverable, strangely optimized, Swan comes across as a behemoth, deliberate, unyielding, apparently impervious. Its already epic tail exhibits faint propulsion twitches that resist basic evaporation explanations. Detailed imaging reveals subtle, periodic wobbles in the tail's alignment, as though the body is adjusting its trajectory. With targeted discharges of plasma, every burst shows up as a spike on the light intensity graph, and the sequence recurs so consistently that it's tough to attribute to mere random flares from the surface. The orbital data piles on more intrigue. Swan follows a trajectory that brings it back around the Sun every 22,554 years. Such an extended period overlaps with the end of the most recent ice age. The suggestion is mind-blowing. Should this thing be artificial, it has adhered to a programmed route for a span exceeding the entire span of human society. Remarkably, it shows up right now, alongside Atlas, in the identical solar pathway, precisely during the interval when Earth's observatories are obscured by solar glare. The probability of all these elements aligning accidentally is minuscule. This convergence stokes an intensifying conviction that Swan transcends a typical comet. Its exceptional brilliance, suggestions of sophisticated protective layers, potential reinforced exterior, and the magnitude of its power generation position it as the most imposing visitor to the inner solar system in recorded history. Be it a stronghold, a scout, or an entirely different entity, Swan compels experts to revise established principles and invite speculations once confined to speculative fiction. All the key irregularities documented for Swan and 3-Atlas have shifted discussions from their nature to their potential objectives. When two enormous entities, one with a 22,554-year recurrence, the other tracing a hyperbolic, perhaps extrasolar trajectory, converge so closely, the likelihood of mere coincidence plummets dramatically. The synchronization, the spatial alignment, and the observational blackout have all sparked numerous hypotheses about expeditions. One notion seems almost ordinary, by interstellar measures, a planned overhaul or replenishment operation. Here, the Sun serves as a service station. These bodies might be designed to harness solar radiation or electromagnetic forces for power restoration, information transfer, or diagnostic reviews. The concept aligns well with strategies for long-haul space ventures. On our planet, solar encounters routinely provide slingshot boosts and vitality surges. For scout craft, the Sun represents the ideal spot for re-energizing or data syncing. A darker hypothesis emerges as well. The proximity might signal an operation to intervene, a meeting to retrieve or deactivate a faulty component, or even a clash among competing groups vying for assets. The projected energy outputs, roughly 10 gigawatts for Atlas, an astonishing 10,000 for Swan, indicate the reserves required for deliberate navigation beyond mere inertial motion. Gradual speed increases and tail variations in Atlas, along with fine propulsion emissions in Swan, suggest a degree of maneuverability consistent with operational goals, rather than erratic venting. Consider also the sequence of inspections. Oumuamua in 2017, then Atlas, and now Swan, might form a progression of replies to humanity's century-long radio broadcasts. Successive visitors could embody increasingly intricate devices dispatched to survey, collect intelligence, or advance engagement. Across these models, the Sun plays no passive role. It functions as the energy hub, the assembly site, the signal. The data may not resolve the arguments, but it does pose a fresh inquiry. If this constitutes an operation, what drives it? A 22,554-year loop extends far beyond a mere orbital figure. It delves into the era of the last glacial maximum, when the planet bore little resemblance to its current form. Circa 20,000 BCE, vast ice sheets dominated the northern regions, and environmental shifts influenced the dawn of human societies. That period inscribed traces in Greenland's and Antarctica's ice samples, with strata of particulates and subtle isotopic shifts alluding to abrupt celestial occurrences. Certain scholars note alignments with epochs when luminous extended orbit comets might have passed nearby, depositing not only material but narratives that could have persisted through oral traditions. Central to this concept lies a location termed Göbek. Göbekli Tepe, an ancient settlement in southeastern Turkey dating back over 11,000 years. Its monolithic columns bear engravings of fauna and symbolic designs, including patterns that enthusiasts interpret as celestial trajectories, perhaps comet paths. A few proponents claim these inscriptions chronicle rhythms spanning beyond individual lives, potentially signaling returns akin to Swan. Orthodox perspectives remain reserved. Both archaeologists and stargazers caution that such links are conjectural, reliant on coincidences that might hold no deeper meaning. The contention rages, with detractors emphasizing the absence of concrete links between these prehistoric structures and precise cosmic rhythms. Nonetheless, the chronology proves compelling. If Swan's 22,554-year cycle holds true, its prior incursion into the inner solar system coincided with the planet's thaw from icy dominance, just as early humans began erecting landmarks and monitoring the stars. Whether that alignment stems from happenstance or deeper significance remains an open enigma. Yet, this lingering mystery lends an even deeper legendary aura to what was already a remarkable occurrence. Ultimately, the tale of Swan transcends mere data points or trajectories. It hints at how the cosmos's most elusive guests might have been intertwined with the origins of humanity itself. Between October 8th and 18th, every prominent Earthbound observatory encounters an abrupt halt. Formal timetables label the period as downtime due to solar conjunction, yet the actual curbs extend beyond that. Confidential directives from U.S. Space Command and the European Space Agency instruct personnel to halt all radar operations and detailed imaging of both Swan and 3Y/Atlas amid this shutdown. Certain bids for substitute monitoring get rejected sans rationale. Demands for unprocessed data get subtly redirected or postponed. A few allocation overseers for telescopes, chatting anonymously, mention strict mandates to steer clear of any public comments on these entities prior to perihelion. This leads to an imposed hush right as the decade's oddest celestial arrivals pass through the solar corona, compelling a slim cadre of freelance stargazers and hobbyist groups to step into the void. As the blackout directives landed, institutional voices fell quiet, but the enthusiast communities buzzed on. Bill Gray, a seasoned orbital analyst celebrated for his freely available computations, mobilized a scattered array of home-based skywatchers and modest facilities. His appeal spread through online discussion boards and secure messaging channels. Train your instruments skyward, record each glimmer, and distribute the unfiltered observations promptly. The Ibero Tracker Collective, operating across Spain and Portugal, united their Broadview sensor streams, as whispers from exclusive stargazing circles hinted at improvised strategies to skirt the restrictions via radio arrays and even converted meteorological orbiters. With official bodies staying mum and major facilities sealed off, this bottom-up initiative turned into the sole barrier against complete data scarcity. Pretty much anyone equipped with a scope, a receiving antenna, or free tracking tools could participate. The blackout phase proved more than an obstacle. It served as a summons. If you're after truths, dive into the hunt yourself. Upon Swan and Atlas's return into view, those initial detections could originate from a suburban setup rather than an official facility. The evidence stands firm. A pair of irregular bodies penetrated the sun's inner realm in tandem, bucking probabilistic expectations and sparking inquiries that no organization has addressed.